Good morning, everyone. Today we are going to discuss about the relation between current and voltage. Our success criteria is I will explain factors which affects the resistance. I will analyze the relation between current and voltage. I will solve problems related to current and voltage. So, before going to discuss about the current and voltage, first of all, we will discuss about the resistance. Resistance. As we discussed yesterday, that resistance R, I will write the formula, R is equals to rho L by A. This formula yesterday we derived. See, now from this formula, it is clear that R is directly proportional to L. Means if the length is more, length of the wire, for example, if you have two wires, for example, this is the first wire. Let me take another. So this is one wire, okay? And now, if I will take another wire, like this. Now see, if current will pass through this wire, if I attach this with the battery, this is the battery. Now, current will pass through this wire from here, see. Now, because current is basically electron, so electron pass through this wire. Okay, so inside the wire, the electron will collide with the atoms. So there will be more resistance. So electron will pass from here to here. So the length is less as compared to this wire. So there will be a less resistance. But if this wire is attached with the second here, so what will happen? In this case, you can see that these electrons will pass through this one. So this electron will cover more distance. So it will collide with more atoms. So there will be more resistance. It means that if resistance is more, it means that length of the wire is more. So the relation between resistance and the length is directly proportional. Second one, that resistance is inversely proportional to area of cross section. Means that if the area of cross section of the wire, means the thickness of the wire is more, like this is a wire. So if it is more thick, so the resistance will be less. So this is inversely proportional relation. Okay, and then this symbol rho is known as constant, and it is known as resistivity or specific resistance. So from this equation, we can find out the specific resistance, how rho equals to, rearrange this formula, R A by L. So from here, you can see what is unit of resistivity. See, unit of resistance is ohm. You write ohm. Unit of area is meter square, divided by unit of length is meter. So this meter will cancel with this square. So the unit of resistivity is ohm meter. So ohm meter is unit of resistivity. Okay, so this is the mathematical portion. We discussed how we can find out the resistance. Yesterday, we discussed how we can find out the resistance by using the color code. And this is the formula with which we can find out resistance. So we will do some examples also. And then it will be more clear for you to find out the resistivity. Let's see. This formula I told you, R is equal to rho L by A. Remember this thing that different material has different resistance. So that's why it's rho, I told you, resistivity. That is specific resistance. For example, this is a carbon, this is a copper. So carbon has its own resistance and copper has its own resistance. That is called specific resistance and it is represented by a symbol rho. Okay. So this formula I told you. Now here is the table in which you can see the resistivity of different materials. See, here is aluminium. Its resistivity is 2.8 to 10 power minus 8 ohm meter. There is copper, 1.7 in 10 power minus 8, iron, mercury, and so silver, tungsten, etc. There are different materials, and different materials have their own resistivity. Okay, these are the constant values of resistivity. Okay. This is a practice question that what is the resistance of 0.00200 meter long carbon core resistor having a core diameter of 0.0000100 meter? Assume the temperature is constant like this one. This is a carbon resistor. So its length is given. Okay. And see, I will underline this thing. See, 0.002 meter long, so this is L, and diameter is given. This is D. Okay, diameter, remember, from this distance. This thickness is given. So what is resistance? As I told you, formula for resistance, R equals to rho L by A. So you need rho, that is specific resistance of the carbon, that you will find out from you will get from the table. I will show you. See, the copper resistivity is there, 1.710 power minus 8. Sorry, this is copper, or we need carbon. So for the carbon, where is carbon? Yeah, carbon is here, 360010 power minus 8. Okay, this is the resistivity of the carbon. And what else we need? We need the length. So length is given 0.002 meter. And we need area. But remember, area is not given. Diameter is given. We will calculate the area. This is now cross section. Okay. So area of cross section is, how we can find out? A equals to pi r square. Okay. By using this formula, just we will substitute the value and we can calculate. See, now this is area of cross section. This is length. Length is given 0.002 meter. Okay, and diameter you will find it is given. This is the diameter. Okay, 0.00010 is also given. Just you will divide the diameter by 2. You will get the radius. Okay, and then just I will substitute 1 minute here. So just we will substitute values. Okay, resistivity rho times length, that is 0.002 divided by pi r square, that is 3.1 1,4 pi into R. R is D by 2. Okay. So what is diameter D? 0.0001 by 2. It's square. Why? Because R is D by 2. So when if it is R square, so you write D by 2 square here. So D is 0.001 divided by 2 whole square. And specific resistance, its value you will calculate. That you will write from the table and then multiply and divide. When you will simplify, you will get the answer. So I will show you the answer from here. See now, this is the specific resistance 3600 10 power minus 8. R is rho L by A. This is the formula which I told you. Just by substituting values, you will get answer that is 9.17 ohm. This is the resistance of the carbon resistor. This part only. Remember, this is the resistance. Remember, its specific resistance is given, that is 3600 and 10 power minus 8 carbon. But the resistance of this length and this diameter is 9.17. Okay, then we go ahead. Now Ohm's law. What is Ohm's law? Ohm is the name of scientist, and Ohm actually studied the relation between current and the voltage. And according to Ohm's law, if the battery is large, for example, just I will give you the example that, for example, there is a circuit, and in this circuit, this is a bulb. Okay, this is negative, this is positive. See now, if it is 6 volt, okay, and here another one, volt. So you will see that now you can see here, this is 6 volt battery and this is 12 volt battery. So 6 volt battery, you can see brightness is less as compared to this one. Why? Because here voltage is more. If the battery is more, means large, the brightness will be more. So it means current will be more. So it means we can say from here that V is directly proportional to I. Means more the voltage, more the current. Okay, so just replace proportion sign. You can write V is equal to I R, where this I is current and R is known as resistance, and it is constant. So according to Ohm's law, if a current passing through a resistor, through a circuit, then this current is directly proportional to voltage at constant resistance. Okay, so V equals to IR. This is Ohm's law equation, where R is resistance, I is current, and V is voltage. Okay, I hope it is clear. Just I will explain more from here. This is the Ohm, the scientist, and this is equation V equals to IR, which I explained for you. Now, say V equals to IR, it shows the relation between voltage and current. So there are some substances which follow the Ohm's law that are called ohmic substances, And there are some substances which does not follow the Ohm's law, that is non-ohmic substances. Remember, ohmic and non-ohmic means when we are saying that V and I directly proportional. This is V, this is I. Okay. If we want to plot a graph, directly proportional means that it will be straight line. Means V increases, I increases, and R is constant. This is Ohm's law. Okay, but there is a condition, remember, when this law is valid at constant temperature. I will write here exact definitions of Ohm law, that current passing through a circuit is directly proportional to the voltage at constant temperature. If temperature is constant, remember, then this is valid, otherwise it's not valid. So temperature should be constant. If temperature is not constant, this law is not valid. Remember this thing. So at constant temperature, you will get a straight line. It means the device which obey Ohm's law, that is called ohmic device. So remember, for this, the temperature should be constant, but this is the ideal condition. If you have a lamp, if you heat the lamp, what will happen? If you have a lamp, remember, if you switch on the lamp, the graph will be like this one, see, and then it will bend like this. Why? Because at the beginning, when you switch on, at the beginning for few seconds or few minutes, the temperature will increase very less. So the V will be straight, V and the graph between V and I will be straight line. But later on, when temperature increases, that lamp become heat up, so its graph will bend. So it is not non-ohmic. It become non-ohmic after that. Okay, so it does not obey the Ohm's law. Why? The reason is that when temperature increases, resistance increases. Remember, so when resistance increases, current will not increase with the same speed, because resistance stop the current. So that's why current will not increase over there. It will slow down, increase but slowly, like this one. So see, now there are the graphs. You have to label the graph, which one is the ohmic, non-ohmic, R increasing, R decreasing, and R constant. See now, this is the first graph, this is the second graph, and this one is the third graph. Now clearly from the graph, in first graph, you can check here that, see here, after that, V is increasing, but R is not increasing. R is not increasing means resistance is increasing. That's why I is not increasing. Because resistance increases, so I will decrease, I will not increase. Okay, and second case, see, it follow the Ohm's law, it is ohmic, it means in this case resistance is constant. Whereas in third graph, you can see current is increasing. So current is increasing means resistance is decreasing. So let's see solution now. First label now. This shows, arrow shows R is increasing. In first case, R is increasing. Here, this horizontal line shows R is constant, not increasing. Here, R is decreasing in third graph, as I told you. And the ohmic and non-ohmic, remember, only the middle one, this graph, where R is constant, it is ohmic. In all other cases, R is non-ohmic because R is not constant. In first case, R is increasing. In second case, R is decreasing. So this is the ohmic, this is non-ohmic, and this is also non-ohmic. I hope it is clear now. See another example. The graph shows the applied voltage V versus the resulting current. See, this is the graph between I and V, and current passed through the tungsten filament lamp. So it passes through the lamp. So that's why you can see I told you that when current passes through the lamp, what happens? It will heat up, so it is non-ohmic. This graph show curves. Find R when I is 0.5 milliampere. See now, I is 0.5 milliampere here. So you will just plot a line here, okay? Then you will get, because we know for the R, actually what happened, for R, we need to calculate the R, we need, because formula from Ohm's law, R is equal to V by I. So we need V and I. So this is V, and you will plot a line horizontal. This will be the V and this is I. Okay, so just I will show you from here directly because it will be straight line. Okay, see now here this is 0.5 I, and here this is voltage. You will calculate it is how much, say 1 2 3 4 5. 5 small square equals to 2. It means 2.5 small square is equal to 0.1, and there are 2 small square, it is 0.08. It should be 0.08 volts. Say at 0.5 milliampere current, V is 0.08. So just substitute the values. Say R equals to V divided by I. V is 0.08 divided by I, 0.5 milliampere. It is milli, so you can write 10 power minus 3. So when you will divide, you get 160 ohm resistance. And second, they are asking also calculate the resistance at 1.5 milliampere. So 1.5 is here. So let's see. So when current is 1.5, voltage is 0.6. Just divide voltage 0.6 divided by 1.5. Answer is 400 ohm. This is the resistance. So from here, what is conclusion that? See, R is not constant. In first case, R is 160 ohm. In second case, it is 400 ohm. So R is not constant. So this is not ohmic substance. It is a non-ohmic substance. From the graph, it is also clear it is a curved graph. It is not a straight graph. Explain why filament might not be non-ohmic. As I told you that because when current passes through, this filament will heat up and its temperature will increase. The temperature will not remain constant. When temperature will not remain constant, it means Ohm's law is not valid. There is another graph now, VI graph. Sketch a graph. Now we have to sketch a graph here. Exact graph. How? See, it's mentioned that for 40 ohmic component in the range, so of 0.0 volt and 6.0 volt. So 0.0 volt is here and 6.0 volt is here. So just we will mark the line. See, we, as we know that V equals to IR. R is, if R is constant, because it's written over there, R is 40 ohm, so it is constant. So graph should be straight line, and you will see that how it is straight line. V equals to I R. R is 40, so I is equal to V by 40. Okay, and if V is 0, see now, I just rearranged from this equation. V equals to IR. R is given 40. Okay, so you will write I is equal to V by 40. Now the condition is, if it is first condition, V is 0. So when V is 0, so you can write I is equal to 0 by 40. That is 0 voltage. So 0 volt is here. So you will mark across here. Okay, so you will see how where it marked. Yeah, you can see this is the first point. Now in second case, when V is 6, so when V is 6, you will write 6 divided by 40. So 6 divided by 40 is 0.15. So 0.15 ampere is the next current. Okay. So 0.15 is 150 milliampere. Okay, you can write 150. Where is 150? On the top, you can see at this point. In the bigger it is in the milli. So when V is 6, I is 150 milliampere. So you can draw a straight line like this. Now this is a linear graph, so it is a graph for the ohmic component. Okay, so now I will give you homework that is about the same topic, whatever we have studied. There is a formative assessment. This is a worksheet. I uploaded already in the Google Classroom. You have to solve these questions from, remember this thing, you will solve these questions from question number 1 to, yes, from here to also this one till this, yes, this, yeah, I think more, let me check. Yeah, till question number 7. Till question number 7, you will solve all these questions. So we have few minutes. So first example I will solve just for your help. See now in the first question, a carbon core resistor consists of a carbon rod having a length of 8.75 millimeter. So this is the length, okay, and diameter is 0.05. This is D, and resistivity, so this is rho. What is value of area of cross section? So cross sectional area you have to calculate. I told you formula for the cross sectional area. We solved the example. A equals to pi r square. So r, you need r. So here is the diameter, this one. Okay, so diameter is 0.005. So r is basically d by 2. So just you will divide this by 2, you will get the r, and then you will substitute here, you will get a area of cross section. Okay, this is answer for the first one. Second, what is the resistance of the carbon? So for the carbon, I told you that formula, again we discussed, R equals to rho L by A. Now rho is given, this one 3500 10 power minus 8. Length is given 8.75 millimeter. You will convert into meter, that is 10 power minus 3. And divided by area, area from here in question number, answer of question number 1, you write. So this would be the resistance. Third part, if current is 1.75 ampere, so what is given? Current I passes through the resistor. What is voltage? So you have to find the voltage. Current is given and resistance you already find out before in question number 2. So Ohm's law, V equals IR. So I is given 1.75. R you will calculate from question number 2. Just multiply, you will get the voltage. I hope it is clear now. You can calculate this one. So same, by using same formulas, just instead of the detailed theoretical question, see here the values are given in the graph. Okay, so from the graph you will take out the values and substitute. You'll find out the till question number 7. So up to question number 7 you will solve today. Okay, and then next lesson we will solve more questions, and when you will complete this worksheet, the whole worksheet, you will complete and send me in through email. I hope it is clear. If you have any question during the class time, I will be available here. Okay, and you can come and ask questions. Okay, thank you very much and see you again. Bye bye.